My hat! Do a quick little speed run. Did I hit the right button? Here we go. And we're gonna see what the difference is with the 3.5mm bullets and then directly soldered on, see if there's a difference. Here we go. Purposely did this in kilometers per hour instead of miles. It's 41 kilometers per hour. The reason why is kilometers are a smaller unit and this doesn't give me decimals. But here we go, second time, so that was 41. Again. If it says 42, I'm going to do it again. Yeah, it hit the one stone in the entire road probably. Alright, here we go. Alright, apparently there were two of them. And it hit both of them. Alright, it says 42. I'm just going to do it again. And it reads 41, so I'm going to take the 41 as the actual speed, and I'm going to assume the 42 was the GPS just flying off of the car. But that being said, now I'm going to take the 3.5mm bullets off the ESC on the motor and do a direct solder and see if it makes a difference on this 25.5 motor with a Justock ESC. Alright, so before I do the soldering, this is the weight. It's about 13, well, it's jumping. 13, I'm going to call it 1353. Right, so I'm just going to remove these three connectors right here and then these little connectors. Just going to use my pliers now. If you've watched some of my other videos, I talk about just using fuel tubing on your pliers. That way it works as an insulator. It makes it a lot easier to solder because then the heat doesn't dissipate into the pliers. So that being said, now the goal is to solder all of these connectors off and then see if it will make a difference speed-wise. Now the theory behind here is that the less connectors you have, the less resistance, because you have more places to lose. Just dump that there. And the more plumbing you have, the worse it is for an electrical system, or anything for that matter. Water system, right? Since I mentioned plumbing. But here we go. Now, the reason why I'm also doing this is a 25.5 turn motor. So it's a really high turn motor, not a high kV motor. And the speed control that I'm using is a Hobbywing Justock. I think the peak amperage on it is something like 60 amps, maybe. I could be wrong. I don't think it's 80. It's probably 60. So again, I don't think it'll make much difference, but I figured I'd test it out. Mainly because I'm not going to be swapping motors in this vehicle. This is going to be the motor that will stay in this vehicle unless I end up replacing speed control and motor in the future. Just don't see myself doing that anytime soon, so I figured I would just do this test since I'm no longer going to be running a 21.5 turn motor on this chassis. So this is going to be my dedicated VTA chassis. It just makes everything so much easier having a dedicated chassis. Still plenty of solder, so there's no point in not liking that. A little too close to the other one. There we go. Alright, let's see, what does it look like? Oh, that is a good solder. Alright, let's go to the next one. So next one, I'm going to go ahead and solder off this yellow one. So this is really it. So the bullet connectors you really only want to use, or at least they're recommended if you need to be removing something. So on some vehicles, that's why they come with it. If you look at some of the products from Castle Creations, they do come with a certain size of connectors. If you look at the larger ESCs, I believe they go up to 6 millimeters, maybe even larger. I'm not sure if they use 8 millimeter. That seems perhaps a little too large for their 1/10 scale items. But the reason why they go to larger connectors is larger connectors, assuming it's the same material, can handle more amperage. And if you have connectors that are too small, you're going to run into a problem. But in this case, with the 25.5, this motor here, I don't think it draws enough amperage to really make a difference. But hey, you know what? Why not test it? And speaking about amperage, that's one of the things too about selecting an ESC. You can buy a top-of-the-line ESC that is rated at 160 continuous amps. The Hobbywing G2 Pro Elite, I think it's the XR10 G2 Pro Elite, is rated at that, and then peak, they have some insanely high number, like 1200 amps peak, or burst, I believe they call it. I don't really think burst is important as continuous. It might be more of a marketing thing, but anyway, the point is, on a motor like this, I don't think it really matters. If it were a more demanding motor, maybe a 7.5, 3.5, something like that, then it would matter. But a motor like this, I can't imagine this motor needing, well, I mean, this ESC has been running well, and like I said, I think it peaks at 60. But even if this motor managed to draw 80 amps, still not, there's no reason to get that other ESC unless you have the extra money to spend. You're looking at about $55 for this ESC, $200, let's say, for the other ESC. And you just want an ESC that runs cooler. I do not know how it would run without a fan, a larger ESC without a fan. Maybe it runs cooler without a fan and you don't really need a fan using a 25-turn motor. Maybe perhaps that's the reason why you're getting it. You want to get rid of this weight up top. But, you know, the fan isn't, well, I guess, no, I shouldn't say it's not that heavy. It's probably 6 to 8 grams, and on something this size, that could make a difference. Although VT is so heavy anyway that it may or may not matter that much. Let's see. Alright, so let's go ahead and remove this guy over here. And we're almost finished. The main thing with when you're soldering off and on and everything's installed, just make sure you're not touching other wires, accidentally burning the insulation on them. That's one of the reasons why I'm applying the soldering gun here, and I'm kind of pulling upward, unsuccessfully pulling upward. There we go. And as I mentioned before, try to have a piece of wood or something down here because you will burn up your mat. Just doing it because I like the contrast. That's the reason why. So it's for the camera. If it weren't for the camera, I wouldn't be doing it here. But we just have one more to go. That's if it wants to cooperate. Oh. Perfect. Alright. Here's our last wire. Oops. Alright, let me just check the soldering job. Yeah, all of that looks good to me. Right, so we are ready to go. So what I'm going to end up doing is I'm actually going to go ahead and tape all of these little connectors on the car. This weight fell off. I'm going to have to tape that again later. And I am using this battery here, and the reason why I use this battery here is I didn't want to charge one of the larger ones. So for the test, I'm actually using a 4200 milliamp hour battery. But I'm going to place this battery in the car. And I'm going to use the duct tape to hold the battery, but because I want to keep a similar weight, I'll try to tape these on as well. And then I'm going to weigh it just to make sure that I have a similar weight. If I do not, I'll just add another piece of duct tape. But it should be. I don't think the difference in the insulation is going to have much effect, to be honest, and that should be good as long as my battery doesn't fly out and damage it. Should be fine. All right, so I'm going to put everything back together, and then I'm going to weigh the car and see how much it weighs. All right, so here's the weight, 1354, and that's with the direct solder. So I want to keep the weight about the same. So it's jumping again. Last time I was jumping between 1355, 1353. I said 1353, but 54. We'll say it's the same weight. All right, so still a little windy. We are starting at 0 kilometers, and here it is. This is soldered on. Is that the mode button? That's the mode button. That's not the mode. There we go. All right. I guess I had on the wrong mode, but it should have recorded. Let me just keep going, and peak.
Wow, reads 43. Let's try it again. Reads 43 again. I'm going to zero it out. I'm going to do it 3 times. I could have sworn I heard a stone under here. Probably not. But let's try it again. That's a big difference. Yep, there was a stone in there. Let me take the body off. Yeah, all of a sudden it just came to a halt. Oh, there it is. It's in the center of the car. It's a good thing my cameraman had spotted it. I mean, then again, it is my wife and she's very good at spotting details. That's why I'm always getting into trouble. See, there's that little stone there. Oh, man. Well, chewed up about half of my spur. Let's see if the rest of the spur can manage. Is the belt still fine? Yeah, the belt's still fine. Well, I know I got it. Well, we saw that 43, so hopefully that, I guess this will be another experiment, see if the chewed up spur makes a difference. Oh, there goes my body washer. There's another one. So, need another spur. Let's see. Alright, zero this out. I have a feeling it's because of the spur, but you know, I'm going to zero it out again, see what happens. Alright, there's a car. I'm not sure if that car is going to turn or not, so I don't want to risk losing my spur and then having a car in the middle of the road. As fun as it may be to stop that car from running over my car, I'd rather not. And another car coming. I think they were all in agreement. They were going to take turns and pass at different times. There we go. Now I'm clear. Calling it 43. Still, there is a difference.
All right, so here I have the car. Now, one of the things that you have noticed, that you probably noticed, is one, the weight did not meet VTA rules, and I know that that's because I was running a different battery. So the purpose of this was not to show you the speed of a VTA car, not at all. The purpose was to show you just to see if there was a difference between a direct solder on or using bullets as bullet connectors. And I'll be honest, I was surprised because a 25.5 motor doesn't draw that much current, so I didn't think the loss from the connectors would be that great or make such a difference on such a high turn motor. On the lower turn motor, sure. But it did. I was surprised. With the bullet connectors, I kept getting, well, it was at 41 kilometers per hour. That's generally what I got. But with this one, it read higher. We're looking at 44, 43, 44. So we're looking at 2 to 3 kilometers per hour. And I chose kilometers per hour for a variety of reasons, kilometers per hour. But the main one, I'm not going to discuss the other ones, but the main ones is the GPS unit that I'm using by SkyRC does not give me decimals for miles, or kilometers for that matter. So I figured since a kilometer is a smaller unit than a mile, if there were a difference, I would see it in kilometers per hour. The thing is, I wasn't expecting to see much difference. I'm actually very shocked and surprised how big of a difference. And many of you are probably looking at this and thinking, well, 1 kilometer is not that much. 2 kilometers isn't that much per hour. But it's huge. That is a huge difference in this scale car. Once you start getting into 1, 2, 3 kilometers per hour difference, it is a massive difference on something like this. So again, it is better to have something dedicated, for example, a dedicated chassis like this, not just because of the setup, but because you can just solder on instead of swapping out motors to meet another class. Unless you swap out the ESC as well, then every time you're going to need new tape. But just solder on. Just imagine if it made that much difference on something that runs so little amps. Imagine on something higher. I don't know yet. Maybe you can write down in the comments if you would like to see the test. Next thing you know, I end up doing the other test before many of you get a chance to comment. I'm kidding, but now I'm curious if I swap out the ESC with a higher amp ESC, if that would make a difference. Again, a motor, you can put as big an ESC as you want. The motor is only going to draw the amps that the motor needs. It's not going to draw any more. Usually the difference, to be honest, I mean, this is really cool, so it wouldn't even be a temperature test. Usually if you have an ESC that is not appropriate for the motor, what's going to end up happening is you're going to overheat your ESC and fry it. This ESC is fine for this motor. Where you may notice the difference, but I have no way of testing it here, and if I take it out to the track next time I go out, which won't be that long from now, there's so many people I probably won't have a chance to go out, run it, and then do the other ESC, but that's usually what you would want to do. Maybe I'll do it. I'll probably do it. But yeah, so for that other test, you would want to run, just race to a whole heat, 4 or 5 minutes, whatever your track does. Then swap out the ESC with the other one, see if it makes a difference. That's where it makes a difference. But initially, right now, we're comparing the same motor, same ESC. The difference was the connectors, with or without. And the results that I got, it's better to do a direct solder by a lot. That is a big difference between the two. And one of the reasons why that matters is that could make the difference of whether or not you place or you don't place. The other thing too is if the speed was 41 before, 41, I believe I said 41, and now it's 44, you're looking at about a 6-7% difference in speed. I mean, that is massive in comparison. So that's a huge difference. But other than that, that is my little tip. Have a dedicated vehicle, dedicated system, and just do a direct solder. Thank you so much for watching.